Hey everyone, and welcome to The Explainer. Today, we are pushing right out to the extreme edge of engineering. We're going to be exploring how we deploy robotics into literally the most punishing, totally inaccessible environments imaginable. It's going to be a fascinating ride. So, where exactly do we send machines when humans just cannot go? This question really shines a light on our own physical limitations, right? Let's face it, we're pretty fragile. We need oxygen, we need very specific temperatures to survive. But our drive to solve problems, that is absolutely boundless. And that is exactly why we build these amazing robotic proxies to go in our place. Section 1, the interplanetary dune buggy, Sojourner Mars rover. Okay, let's dive into this first grand case study, and we're starting completely off-world. Our source material uses this highly evocative, just totally cool phrase for the Sojourner. It calls it an interplanetary dune buggy. I love that, because it frames the rover not just as some sterile scientific instrument, but as a rugged, highly specialized off-road vehicle. It was literally designed to conquer alien topography using the super innovative six-wheel rocker bogie suspension system. Ultimately, the core purpose of a machine like Sojourner is conducting interplanetary exploration where humans simply cannot go. These machines step up and absorb the extreme radiation, the freezing temperatures, basically taking on 100% of the physical risk. And they do all of that just so we can gather crucial telemetry and expand our reach into the cosmos. Section 2, Mapping Hero Robot Sectors from Space to Earth. Now, this technology isn't just restricted to outer space. Let's scale things back down to Earthbound environments and map out these so-called hero robots. And this brilliantly illustrates how these extreme discovery and rescue capabilities map directly to vital sectors right here on Earth. You see, just as space relies on space explorers, the deep sea relies on autonomous divers navigating absolutely crushing pressures. And we see this exact same thing mirrored in emergency services deploying firefighting bots straight into infernos, or in medicine using these incredible micro-doctor bots. It's just this vast, fascinating ecosystem of specialized proxies. Section 3. The mechanics of autonomy, how hero robots function. So, to really understand how they pull off these crazy feats, let's transition the narrative to examine the underlying mechanics and the specific tools that make these dangerous missions possible. The foundational tool here is autonomous technology. That's a vital tool allowing specialized machines to function independently for discovery and rescue. And for these machines, autonomy isn't just about, a human holding a remote control. It is all about onboard computing. This allows them to instantly react to super dynamic, hostile environments, completely on their own, without waiting around for a ping from a human operator. Now, this autonomy really relies on two fundamental pillars. First up, we have sensors, gathering vital data from the environment. We're talking things like LiDAR, thermal imaging, and spectroscopy. And then second, mobility tools, moving the unit through challenging terrain. That could be articulating tank treads, rotors, or even biomimetic fins. Basically, the robot perceives the environment, calculates a path, and then seamlessly executes the movement. Section 4. Your Mission Design Challenge, the Lost Toy. Let's move to and see how this builds into a practical, localized, and relatable everyday scenario for all of us. If we strip robotic mission design all the way down to its absolute basics, we get a scenario kind of like this. Step 1, identify the problem. Let's say a lost toy under a really dark bed. Step 2 requires selecting the right sensors. In this specific case, you'd probably want to rely on infrared or low-light optics to actually see in the dark, right? And then step 3 is choosing your mobility tools. You definitely opt for low-clearance tracks instead of, say, a tall bipedal design, just so it can actually fit under the bed frame. It's a localized, everyday microcosm of the exact same engineering loops used by NASA and deep-sea researchers. So whether it's navigating the oxidized craters of Mars or just sweeping the dusty floorboards under a bed, the engineering principle is exactly the same. Autonomous technology is a vital tool for discovery and rescue. It literally projects our problem-solving capabilities into environments where our biology simply fails us. So I want to leave you with this final thought. If you could build a hero robot tomorrow, what problem would it solve? Think about the immediate challenges in your own life or your industry, and consider how an autonomous proxy could totally change the game. Thank you so much for joining me on this explainer today, and as always, keep exploring.